So in general, we can center our Taylor series at any x value. So if we center it at x, we've been centering it at x equals 0, but we can do it at any value. And so here would be the general recipe or formula for a Taylor series, centered at x equals a. And of course, you could put, I could have put 1 factorial here, and I even could have put a x minus a to the 0 if I really wanted to be, keep the structure exactly the same. A couple things again to notice is, as usual, the degree, the factorial, and the derivative you're taking all match. And the first two terms are your linearization. The other thing is your partial sum. If you wanted to actually do a Taylor polynomial, that would look like f of a plus f prime of a times x minus a plus f double prime of a x minus a squared over 2 factorial, all the way up to some n that you decide. So that would be called the Taylor polynomial of order n at x equals a. Or we could say the nth degree Taylor polynomial for f of x at x equals a. So polynomials have actual degrees. The series itself goes on forever. And the nth degree Taylor polynomials are used to approximate the function f of x at and around x equals a. Oftentimes you'll be expected to write Taylor polynomials when you're not given the function in detail, but just particular values that will allow you to write the Taylor polynomial. So here we've got a function g of x. It has derivatives of all orders for all real numbers, and we're given some values at x equals 3. And so we want to write the Taylor polynomial for this function centered at x equals 3. So that will just be, so I'm just going to write our polynomial is going to be g of 3 plus g prime of 3 times x minus 3 plus g double prime of 3 x minus 3 squared over 2 factorial plus g triple prime of 3 x minus 3 cubed over 3 factorial. So now it's just a matter of substituting. And that's really all this problem involves. You just have to know the recipe yourself. So it's 6 over 0 factorial plus g prime of 3 is negative 5 times x minus 3 plus g double prime of 3 is 7 plus g triple prime of 3, which is negative 4. And there it is. So I guess I'll put the subscript 3. There's our third degree Taylor polynomial for g of x centered at x equals 3. This is kind of a classic AP exam problem where you're given the Taylor series expansion for a function and then centered at x equals negative 6 in this case, and then you're asked to find certain values of the function, including values at certain derivatives of the function. So the way you do this is you do a matching up exercise. So take p of x, and let's say, okay, we know that the general form of the Taylor polynomial is going to be f of, by the way, that should be negative 6. These should be negative 6s. Sorry about that. These negatives. F of negative 6 plus f prime of negative 6, x minus negative 6, which is x plus 6, plus f double prime of negative 6, x plus 6 squared over 2 factorial, etc., right? So that just means that we want to match up the degree with the terms we're interested in. So, for instance, f of negative 6 is this first number here. It's not attached to any term involving x, so we know that we can match it up with a 9. So we know that f of negative 6 must be 9. How about f prime of negative 6? Well, f prime of negative 6 term, let's match them up. This is the f prime of negative 6 term, and it matches up with this. So we know that f prime of negative 6 times x plus 6 is supposed to equal 2 times x plus 6. And there we can see that f prime of negative 6 is just equal to 2. And then lastly, we want to look at f double prime of negative 6. So f double prime of negative 6 comes from this term, or is involved in that term, and we got to match that up with the second degree. So we know that f double prime of negative 6, x plus 6 squared over 2 factorial, we know that's supposed to reduce and equal, reduce to that. So we can cancel out those, and then just multiply both sides by 2 to get that f prime of negative 6 is equal to negative 7 thirds times 2, which is negative 14 thirds. Alright, so it's a kind of just a matching the structure of the the Taylor series form to whatever you're given, and then match up term by term. So you should be able to answer, for instance, what's the 100th? You should be able to answer this. Maybe you should try this on your own. I should be able to ask you the 100th derivative at negative 6, and you'd want to match up the 100th term with that guy there and figure it out.